Now we're going to start chapter 12. It is about the first derivative in graphs. So all the work that we have done in the past we use here. There's other pieces that we did that I'll pull in because it all in a way meshes together. First thing I need to look at is go back and talk about increasing, decreasing functions. You had this in pre-calc. So first thing, recall that the derivative of a function at a point gives the slope of the tangent line to the function at that point. We've been working with that for the last 3 tests. Number 2, it says a line that has positive slope rises from left to right. A line that has negative slope, it's decreasing, falls from left to right. A horizontal line has a slope of 0. Now I've got this function that I would like to graph. I've already started it in my calculator. Window, this is your x's and this is your y's. So let me go to my window. I've got a negative 2x min and 11 x max. Scale is 1. Scale is how often the tick marks are given. Negative 300, 300, 50. Larger these numbers are, the larger the scale is going to be. If you had this a 1, you might try it. It'll look like a double axis. So when the numbers get big, then the scale must also. So I'm going to ask the calculator to graph. Okay. In pre-calc, we would go find out this point because we could tell someone that this curve is increasing from negative infinity to right where it tops out, right there. Then this curve, if you'll notice, the slope is negative. All my tangent lines from my max here to the min here, from the min, this min, to this max, if you'll notice my curve is going up, which means all my tangent lines would have positive slope. Then from this max to this min, my tangent lines are negative. Also, my curve is decreasing. And after this last min, my curve is increasing. So the number 2, 3, and 4 deal with tangent line slope. Number 1 deals with derivative. So I know at this particular point where my cursor is pointing, at this one, that min, that max, that min, all my tangent lines have a slope of 0. And I will use that to help me get information. Now, me giving you this window, you're going to be able to find this window also once we start learning how to use the derivative to do that. So let me see if I can move this a little bit. It says, think of this graph as a roller coaster track. The floor of the car, if you've ever been in a roller coaster, as it moves from left to right along the track, represents the tangent line at each point. Using this analogy, we can see that the slope of the tangent will be positive when the car travels uphill and y is increasing, and the slope of the tangent will be negative when the car travels downhill and the y is decreasing. In this case, it's also true that the slope will be 0 at peaks and valleys. Let's see what else I've got. The derivative, your f prime, your y prime, can change signs from positive, negative, or negative to positive at points where the derivative is equal to 0, and also at points where the derivative does not exist. The values of x where this occurs are called critical numbers. By definition, critical numbers for a function f are those numbers c in the domain of the original for which my derivative of that value is either equal to 0 or it does not exist, but my original does. We also have another type of number, partition numbers, and these are numbers C where my derivative and, notice there's an and here, my original does not exist. So this is like when I have rational expressions where I can't have division by 0. And if you remember when we do our quotient rule, that denominator gets repeated and squared. So if it doesn't exist in the original, it's not going to exist in my derivative. Now both critical values and partition numbers are going to have to be put on a number line. Let me see what else I've got. First derivative test and a sign diagram. Locate on a number line those values of x for which the derivative is equal to 0 or the derivative does not exist. These points determine several open intervals. So the derivative, I'm going to have to find my derivative, I'm going to have to graph it, and I'm going to have to find my zeros or breaks. Now number 2, it says choose a value of x in each of the intervals determined in step 1 and use these values to decide whether the derivative is positive or derivative is negative. Guys, I use my calculator and I use the graph. I'll show you this way that they're referring to, but we can get the information a whole lot quicker by looking at the graph. But in number 2, it says if the derivative is greater than 0, meaning it is positive, slope is positive, and f, the original, if you'll notice, is increasing on the interval. If the derivative is less than 0, which means it's negative, then the original is decreasing. We're going to use plus or minus in those intervals to indicate whether f is increasing or decreasing. Okay. Now the derivative of the prior function. Let's see, let me get my original back up here. It's up there. So if you got this derivative, that would be 5x to the 4th minus, if you go 4 times that, it should give you that 92, x to the 3rd. 190 times 3 is 570, decrease power by 1. Negative 690 times 2 would be that negative 1,380. And then that would be just plus 1089. And then remember, a constant goes away. So let me go back over here. I'm going to turn this off a second. And let's go type in this derivative. Got 5x raised to the 4th minus 92x cubed plus 570x squared minus 1380x plus 1089. Okay. Now I turned the first one off so it will not graph. So let's see this one. Okay, guys. You've got to understand this is my derivative. These are zeros right here. That one, that one, that one, and that one. Since this is my derivative and those are zeros, this is where my tangent line is horizontal. This is where I'm going to have a max or min. So let's go find this first 0 and see if it matches up to that 1.58. So second calc, 0. It's between 1 and 2, so I'm going to type in 1, enter, 2, enter, and I don't guess. That's where I got 1.58. You find all your zeros. Let's go try this one. Second calc, 0. It's between 2 and 4. You can either use your cursor or just tell it an x value. I think it's easier, or faster, I guess, just to use an x value. I don't guess. That's where 3 came from. So you can find the other zeros. You should be able to find out exactly what I've got. Now with this still present up here, we found our zeros. Now notice this is what I call a sign diagram. Up top are my value, what my value of my derivative is. And so right now I know this is 0, 0, 0, and 0. And at what particular x value. Now this is what they're saying is go find those zeros, and this creates open intervals. And I'm going to show you where these signs come from in just a second. Now since this is my derivative, I'll show you a couple of ways. I could do second trace for value and choose an x value. When I do second trace for the calc menu and value, it prompts me for an x. So I'm going to put in an x value around these zeros and see what my sign is. So let me type in 1. Notice it's a positive 192. You don't put the number, you just put the sign. Now what I want you to see is when I was talking about I look at my graph, regardless of what x I use to the left of this 0, it's all above the x-axis, which means they have to be positive. Between these two zeros, notice where y prime is. It's going to have to be negative. Let me type in 2. There's my negative. Now if you want to actually see where it is and see the sign, I leave it up to you. But I just look at it and I can tell if it's going to be positive or negative in a section. Between the second and third 0, between 3 and 5.58, my derivative is above, which means it has to be positive. Between the third and fourth, notice my derivative is below. Let's see, 1, 2, 3, 4, 5, 6. Let's type in 7 and see if I do not get a negative. There's my negative 192. Anything past this last 0 is going to be above. So that was 7, 8. Let's try 10. Just a positive 2,289, but it's positive nonetheless. Now my critical numbers, this is where my derivative in this particular problem is equal to 0. So here are my critical numbers: 1.583, 5.58, 8.24. Function increases. Wherever you see a plus, the function original is increasing. So there's the interval notation to indicate that. The negatives, 1.58 to 3 and 5.58 to 8.24 is negative, and that means my original function is decreasing. So let me get the calculator back up. I'm going to turn y1 on. Now the one that's going to be graphing is our original. I want you to look. At your zeros of your derivative, that's where I'm going to have a horizontal tangent. I've got one here, here, right here, and also right there. See, there's my 0. And guys, I know there's multiple graphs here, but when you're looking at one, you can get a lot of information about that. Okay, so this pretty much is what we're going to be doing. We need to get used to this. The next example, I've got find any critical values for the following function. I had to rewrite this to x to the 2/3. Got my derivative. Now notice right here, 0 is legal on this one. 0 is not legal down here. My critical values, there are no values where x can equal 0, but x can't equal 0 since it would lead to division by 0. Since x equals 0 exists in the original but not in the derivative, it is considered a critical value. So let me get my calculator back up. Let me clear these. Let's go put in our derivative. I've got 2 divided by, I need parentheses here, 3x raised to, now since my exponent is fractional, I need parentheses. So that closes my exponent. Another parentheses will close my denominator. I really messed up my window. To unmess it up, do zoom 6. Let's see what happens. Now this is my standard window, and looks like things are going on right in here. A lot of times if it looks like it's going within plus or minus 4 of the origin, I will do a zoom 4, which is decimal, and it gives me a prettier picture. Okay, notice I've got a break. Let's see about my signs. Notice my derivative is not defined because I can't have division by 0. Notice to the left of an x value of 0, it is below. That's where that negative came from. To the right, it is above. That's where the positive came from. So this function is decreasing from negative infinity to 0 and increasing from 0 to infinity. So let's see what's going on with this. Let me clear this out. Let me type in the original. X raised to the 2, divide by 3. Let's get to graph. That looks like a sharp point. Notice it is decreasing, it is increasing. I've got myself a minimum right there. So this is what we're going to do. We're going to be exploring using the derivative to give us information about the original. Now the existence of local extrema, that's your max min values, if it's continuous on the interval from A to B and C is a number in that interval, f of c is a local extremum, then either the derivative is equal to 0 or the derivative does not exist. So in this prior problem, that's an example of where my derivative does not exist, but I actually do in fact have a minimum. The prior one, the one that was x to the 5th, it had, my derivatives were 0, and I had a lot of max and mins up there. So you've got some problems that you need to do. I'm going to do some more examples, and I'll attach those. Thank you. Bye-bye.